Okay, question 4. A rectangle has an area of 54 square inches and a length of 6 inches. What is the width in inches of the rectangle? All right, so if you look at this, it says we're actually trying to find the width. So this is our unknown, but they mentioned the fact that we got area. So if we go to our formula sheet, which again you can pull up on the GED, so you don't need to memorize these, you just need to be able to know where to find them. So it's worthwhile spending some time interacting with the sheet so you know exactly where to find them. So area of a rectangle, so area equals length times width. So we know that the area is 54. And here they tell us that the length is 6. So 54 equals 6 times W. So if we want to isolate W, what we're going to end up doing is divide by 6 on both sides. Okay? And these are going to cancel out. And W is equal to 54 divided by 6, which is 9. The other thing you can do is you could just go through basic trial and error here. Start with the top one, and you could do 9 times 6, and you'll see that does equal 54. You don't have to go any further. If you did 6 times 21, well, that's going to give you 126. So we're way over our 54 here. So our answer is A here. All right, number 5. So the Wilson family backyard is a rectangular plot that has a length of 100 feet and a width of 80 feet. The family planted a garden and with a length and width of 60 feet. The family planted a lawn in the remaining area of the backyard as shown. The question is, what is the area in square feet of the lawn in the Wilson family's backyard? All right, so let's deconstruct this one a little bit here. So they planted a garden. So let's call, if you look, this is the area where they planted the garden. Okay, right here. Just trying to decode this. So here's the garden, and then it said the family planted a garden and the family planted a lawn in the remaining area as shown. So in green, this is the lawn. Okay, you don't need to know this. I'm just trying to tell you what, where did this beginning part here, a rectangular plot has a length of 100 and a width of 80. That's this whole thing here. If we were to draw a box around this whole thing would be 80 by 100. Okay? What we're trying to find is what is the area of just this green part here, this kind of L. All right? And so let me show you the process for this. First thing is we're going to redraw it, because remember you're going to be taking this on a computer, and so you're going to have to act like you're redrawing it on a sheet of paper. We're going to label the distance on all sides, separate it into individual shapes, and then we'll solve for each individual shape, and then we'll add the areas together. All right, so if we redraw this, okay, something, we're not looking for artistry here. All right, we know that this side is 80. We know that down here is 100. Here's 60. And they give us here is 60. Well, if this whole thing over here is 80 and this is 60, so if we want to add this one, it would take another 20, because that's going to be 80 minus 60, which is going to be 20. Okay? And then up here, this is the other one we don't know. So we know this whole thing is 100. We know that this portion here is 60. Well, what is 100 minus 60? So 100 minus 60 is 40. So that means up here this is 40. So now we have all the lengths. Now we need to separate this into individual shapes. I think it's easiest to do it like right here. We're gonna separate it, so we'll have kind of the top, the vertical part of our L, and then the horizontal part of our L. And ultimately we're gonna add these two together. So this one is 40, and the height is 80 now. If we look over here, the length is going to be 60 and the width will be 20. Okay, you can go ahead and enter these in the calculator if you need to, but this one is going to be 3,200. It says 8 times 4 is 32, and add 2 zeros. Okay, 6 times 2 is 12, and add 2 zeros. So we have 3,200 for this section and 1,200 if we add these two together. So 3,200 plus 1,200. So 0 and 0 is 0, 0 and 0 here. 2 and 2 is 4, and 3 and 1 is 4. So A is our answer here. All right, question 6. Greg installed a circular drain that has a diameter of 4.8 inches. Question, to the nearest tenth of an inch, what is the circumference of the drain? All right, so again, I've taken a screenshot here of the formula sheet, and under the perimeter section, you can see there's circumference of a circle. So circumference is kind of, it's the perimeter, essentially. And they give us two different equations. You've got circumference equals 2 pi r, or circumference equals pi times diameter. That's because the diameter is equal to 2r, or the radius is equal to the diameter cut in half, or half the diameter. So if you know one, you can easily find the other. In this particular case, we have the diameter. This is the length of the diameter. If we go from edge to edge through here, that's going to be the diameter, so 4.8. So we're going to use this formula here, where they tell us pi is equal to 3.14. So we're going to take 4.8 times 3.14. Let's assume you can use a calculator. Let's clear all this. So 4.8 times 3.14 equals 15.072, and it says to the nearest tenth, so 15.072. So this is where we want to round to the tenth. Okay, so we're going to look at this one, and if it's more than 5, we're going to add 1. Okay, and that's to right here. So we're going to add 1 because it is more than 5. If this were 15.03, again, we wanted to round to the nearest tenth, we would leave this here at 15.0. So normally I find test makers are actually a little bit trickier than this, and they might have given you 15.0 as an answer choice. And so you would round to 15.1 because of this 7. All right, number 7. The foundation of a building is in the square of a rectangle with a length of 20 meters and a width of 18. It says, the question, to the nearest meter, what is the distance from the top left corner of the foundation to the bottom right corner? So, in other words, top left to bottom right. So over here would also be 18. Okay, and up here would also be 20. So we want to find this length here. So this is a Pythagorean Theorem problem. Again, here's a screenshot from the formula sheet. You have Pythagorean Theorem, which is a squared plus b squared equals c squared. So a diagonal one here, which is also called the hypotenuse, is going to be c. The shortest distance is typically a, and the middle distance is b. So if we take this formula, a squared plus b squared, this is what I would write on my scratch sheet of paper. A squared is going to be 18 squared plus 20 squared, and that's going to equal c squared. So you can use a calculator here, and let me show you. You could do this in at least this first part here in one step. So let's do 18, and here's your squared button right here. You can see the little 2 pops up, plus 20 squared. And that's going to, well, we will enter that in, we get 724. So let's go back. So now we have 724 equals c squared. So how do we solve for just c? Well, x squared in the inverse, the other inverse operation is going to be taking the square root. So these are inverse operations here, just like multiplying and division or adding and subtracting are inverse operations. So if we take the square root of c squared, these will cancel out and we'll be left with just c. So on this side, we're going to take the square root of 724, and that's going to give us the length of c. So let's go back to our calculator, and the square root button is right here. Okay, so we're going to do second to get that green lettering, and there we get our square root or our radical sign, and we're going to enter in 724 and hit enter, and we get 2 square root of 181. Often students are confused because that isn't an answer choice. Okay, if we quickly just peek at the answers again, we have whole numbers here as answer choices. It does say to the nearest meter. All right, so if we hit this double arrow button, this is going to convert into a decimal, and we get 26.90. Okay, so this is going to be 26.90, which we can see we've got B here is 27. All right, question 8. A sphere has a radius of 7.5 centimeters. Question, to the nearest cubic centimeter, what is the volume of the sphere? Again, this is from the formula sheet under surface area and volumes. All of these right here have to do with surface area. SA stands for surface area. Well, what we want is the volume. So we're looking in this column, and we want the sphere. So we want this one right here. All right, so we can do this all in the calculator. So the volume will be 4/3 times pi. So we'll do times 3.14. I'm using the dot here for multiplication. And then times the radius, which is 7.5 cubed, or to the 3rd power. So let's enter this all in the calculator over here. Let's clear this. We got a blank slate. So I would use n over d for the fraction. So n over d, you can do 4 down 3 and then over times 3.14 and then times 7.5, and you're going to do this kind of arrow up button here. That's going to give us our kind of our exponent, or in this case where we can put our 3. You see it blinking there, and then we can hit enter and we'll get our answer, and we get 1766.25, and that is one of the answer to the nearest cubic centimeter, C, 1766. All right, question 9 here. The line graph shows the monthly payroll at a large construction company. In which month did the monthly payroll decrease the most? Okay, so it's interesting. When they say decrease, I think they're referencing it from the previous month. So when they mention February, you have to look at the previous month, which is January. And they mention March, you have to look at February. So if we go down, let's look at each of these answers. So from February, what we're really looking at here is from January to February. So this is going to be answer choice A. Well, January, you have to kind of just estimate here. Let's say this is 62. And then February, let's say that's 44. Okay, and so that's a difference of 18. So it went down 18. Let's look at B. So from March to February, if we go from Feb to March, well, you can see that's this here. That's this section here. This is actually an increase. So we don't even have to do this math. It's rising. We're looking for a decrease. So March is not going to be the answer. If we look at C, June. So June is right here, so we have to look at the previous month of May. And so May to June, the end of May to the end of June, which is, again, the whole month of June, effectively. May, let's call this 78. And June, let's call this 55. So if it goes from 78 to 55, that's a difference of 23. That's a decreasing 23. That's much greater than A. And let's check out July. So from June to July, it is a decrease, but you can see it's not nearly as steep. So the other thing that you're doing, these are slopes, effectively. You're figuring out the slope. So really, we're looking at this slope and this one. Which one is steeper? And it's going to be the one that goes from May to June, or the full month of June. And that's going to be our answer. This one is also a decrease from June to July, but you can see it's not nearly as steep of a decrease. All right, question 10. The manager of an apartment complex ordered the air conditioners in the apartments to be replaced. The list shows how many years each air conditioner had been in service. What is the median number of years that an air conditioner has been in service? Well, this is actually interesting. Maybe, let's say you forget median. You don't remember. Well, that's actually in the formula sheet as well. So here's the full formula sheet right here, and underneath data it says median. Median is the middle value in an odd number of ordered values of a data set, or the mean of the two middle values in an even number of ordered values in a data set. So if we go back, the first step I would do is count how many of these we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 of them. So what we have to do is we have to reorder these from least to greatest. So from least to greatest. So you want to find the smallest number. So we got 11.9, 11.9, another one, 11.8. And sure enough, 11.8 is going to be it. So if we do, we'll have 11.8, 11.9. There's another 11.9. There's a 12.2. There's a 12.3. The next one is 12.9. 13.3. There's a 13.4. And 13.6. And lastly, a 13.7. So let's make sure that we have included all of them. Making sure I got all my apostrophes here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a major mistake that students make, is they don't verify. Because if you do 9, or let's say you even do 11, you'll get the wrong answer. All right, and so what we need to do is we need to find the ones in the middle. And so if I use kind of a different pen here, and let's cross off these 4 on the left and then these 4 on the right, we're left with these 2 here in the middle, okay? And that's what's going to happen. When you have an even number, we need to find the average of these 2 in order to find the median. So what we're going to do is take 12.3 plus 12.9, and then we're going to divide it by 2. Because there's 2 numbers, this is effectively finding the mean or the average of these 2 numbers. So if you add these 2 up, you will get 25.2. And if we divide that by 2, we will get 12.6, which is C. All right, question 11. A restaurant serves custom-made omelets where guests select meat, cheese, and vegetables to add to their omelet. There are 6 vegetables available, and guests may select any 2 vegetables for their omelet. How many different combinations of 2 vegetables are possible? So this is a true thinking problem, where you're going to have to kind of create a system that allows you to count the different options. So first thing I would do is think, well, let's just put a symbol to each of these vegetables. Let's be really simple about it and call them A, B, C, D, E, and F. Okay? So here's our 6 vegetables, and we have to have a combination. So if you create A, B, C, D, E, and F over here, you will be able to, now we can create kind of a grid here. So we're not going to include A with A because that's not a combination. That would just be like having all onions or double onions or something. That's not going to count. But A would be, A crossed with B would be 1. So notice I'm just kind of going down. A with C would be 1. A with D would be a combination. A with E, and A with F. So now if we look with B, we're actually not going to include A with B here because we already have it here. So the next one is just B with C. Again, we're also not going to include B with B for the same reason that we didn't include A with A. So B with D would be a new combination, B with E, and B with F. So if we look at C, again, we're not going to include C and A because it's right here, okay? And we're not going to include C with B because that's right here, right? B and C are right here. So, and we're not going to include C with C. So the next one is right here. Hopefully you're starting to see a pattern. Okay, we started off with 5, now we have 4, and then 3. And if we look over here on D, we're not going to include A and D because we already have it right here. We're not going to include D with B because that's right here. We're not going to include D with C because that's right here. So the next one is D with E, okay, and D with F. And again, you're not going to include D with D. And then E, we're not going to include E with E. We already have D and E. We already have D and C, E and C, and E and B, and E and A. So the only new unique one is right here, which is E and F. Now, for F and F, well, we have all those. Here's F and A. Here's F and B. Here's F and C. Here's F and D. Here's F and E. And again, you would not do F and F. So if we count all these up, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, and then 3 more, and 2 more, and 1 more, you can start to see the pattern. So if you add all these up, 5 and 4 is 9, plus 3 more is 12, plus 2 more is 14, plus 1 is 15. So there's 15 unique combinations. So that's just one where you kind of just have to think your way through the problem and create a drawing or a picture to help you figure that out. All right, question 12. In a shipment of toys from a manufacturer, the probability that a toy is defective is 1 out of 50. If Marie selects 2 toys from a shipment, what is the probability that both toys are defective? Okay, and you got 1 over 25, 1 over 50, 1 over 100, and 1 over 2,500. All right, so I'm going to draw a connection here to try to help you figure out how to answer this one. And I always draw the connection to flipping a coin. So what is the probability of flipping a coin twice and getting heads both times? Okay, very similar to what we're talking about here. What operation do we use to combine probabilities? Do we add them or do we multiply them? Sorry, that's a typo there. Do we add them or do we multiply them? So if you look at what is the probability of flipping a coin and getting the heads? Well, it's 1/2, right? What is the probability of flipping a second coin and getting heads? Well, it's also 1/2. So how do we combine these? So you either add them or you're going to multiply them. Well, if you add them, 1/2 plus 1/2 equals 1, which is equal to 100% of the time. So ask yourself, if you flip 2 coins, are you always going to get heads both times? No, you're not, okay? And so adding isn't what we're going to do. We actually need to multiply them. So when you multiply fractions, you're going to multiply straight across. And 1 times 1 is 1, and 2 times 2 is 4. So getting heads twice, 2 different flips, you have a 1/4 chance. So if we go up here to our problem, we're going to take 1 over 50, and we're going to multiply it by 1 over 50. And again, you're going to do 1 times 1, and then 50 times 50. Well, 5 times 5 is 25. And then we have 2 different zeros that we need to add, or 2,500. Again, if you want to use a calculator, feel free to. It's just, again, 50 times 50 equals 250. Or you can even do n over d, 1 down 50 over multiplied, n over d again, 1 down 50, and then hit enter, and you'll get 0.004. Well, if we want that into a fraction, you hit the double arrow button. They're not going to give us that as a fraction, huh? Let's see if we can force it. Let's do second and this button. No, they don't want to give us that as a fraction, unfortunately. That's interesting. So hopefully, when I showed you how to do 50 times 50, you can see that D is going to be our answer here. And that's it. Thanks so much.